Good morning.
Hello, good morning.
Good morning to our
Ayan.
fellow educators all over the Philippines, Luzon, Visayas, and Mindanao, and across the country who's now watching. Stay tuned, and we're very excited for today, Miss Joy.
Yes, sobra. This is our day 2 of virtual robotics. So kung kahapon medyo kinilig at pinressure at the same time. Pero yun nga, hashtag ko yung sinabi ni Ma'am Mylene na hashtag hard fun. Di ba?
Yes. So yesterday was very fun and somehow talagang nag-twist ng konti ang ating mind to follow the instructions, to build our own robot. And I believe na maraming teachers ang na-challenge, but of course, that's part of the learning process.
Alright. So, ang daming team replay kahapon, kaya feeling ko nasundan nila at nakagawa sila ng kahit simpleng output this morning. Okay?
Yes, Miss Joy. So, as requested by Miss Mylene, we are tasked and we're asked to speak in English because this training will be also broadcast to Lego Education, or they will going
Alright.
to share this how we teach, how we deliver, how we connect to our educators in terms of sharing Lego in education. So, we're very excited
Okay.
to share this to the world. How the Filipino educators are very active, very welcoming, and very uh, who who would like
You know,
to open or open-minded for new ideas, Miss Joy, right?
yes. Filipino teachers have this passion in their heart, okay, as they want to share their learnings to their students.
Yes. So
Okay?
even though for some it's robotics is intimidating, but for us we are very much willing to learn, and we are very passionate in terms of learning new things. So before we begin our
Yes.
session, let's have Miss Joy an opening prayer for us to be blessed, and our training will be blessed
Okay.
for the whole day.
Okay. Um, Lord God, we thank you for this wonderful morning. Thank you for the speakers that will share their knowledge and expertise in our training for this morning. Guide us as we have our day 2 of virtual robotics, that the teachers, the students, and parents as well learn something new about this robotics training. We thank you for blessing us the gift of life, the gift of wisdom, as we have this webinar this morning. We ask you to guide the speakers and bless also the participants as we have this robotics webinar. All this we ask in Jesus' name. Amen. Amen.
Amen. Thank you,
Yeah.
Miss Joy, for that heartfelt prayer. So we all need that,
Thank you.
especially today in this pandemic. And but still, education must continue. And we're very excited for today because we heard that we will have, other than the learnings that we're going to learn, is we do have a raffle, and our teachers are very excited. So
Yay!
we saw, actually, Miss Joy, we saw a lot of very amazing outputs of our educators, their
Yes.
ducks from Lego, and also robots that they were able to build.
Yes. We're very excited to see their output later.
Yes.
Okay.
So to begin our session, we let us all welcome again the territory manager for Southeast Asia Lego Education, Bill and Denmark, Mr. Brian Dam. So good morning, sir.
Morning, Sir Brian.
Good
Good
morning, Brian.
morning. Good morning. How are you?
We're
Yeah,
good.
we're great, sir.
Perfect. Perfect. So, thank you very much again for allowing me to talk a little bit. Very excited to be here again. Thank you for yesterday. I think it was a very nice and informative session we had, and thank you for all the positive feedback so far.
Yeah.
So today we have the joy of getting our hands even further deeper into the program, starting now the learning journey again with hands on, our minds on, trying to build confidence, of course, by practicing and by doing it. I hope you had some good experiences yesterday. Hopefully, also a failure or two, but building upon failure, and by that
I failed a lot.
growing. Exactly, but once you get used to it, this is a simple and natural part of the learning journey, and I think that's an important step, and we take another important step today when we start to program in a virtual environment. So that's going to be an exciting journey, I think, for everybody, and it's going to be super great.
Yes.
Yes, Brian. So it's good to know that we teachers is human also. We did or we do mistakes. We need to accept that. We need to also share that to our learners, that even as a teacher, I also fail. That and failing is okay, because it's part again of the learning process, and we need to build that confidence.
Exactly, and that goes for both students and teachers. It's again that is exactly what we would like to see, and how things are operating also outside of the classroom. So it's a perfect way of learning to accept your mistakes and your failures, and then growing and becoming much greater at it. So yes, I think, at least from my end, with those words, I hope that you will enjoy very much the next couple of sessions that will be hosted. I'm sure there is a lot to learn and a lot to do, and a lot of confidence to be built.
Sir, have you seen some of the outputs yesterday of the Filipino teachers?
Yes, I have.
Yeah. So, what can
So
you
how
say,
was it?
sir?
No,
How was it?
I think it's amazing. I think
Ooh,
it's great, and I like all the different ideas and such. So
ah,
it's amazing, I think, and I
yay.
think that they should all, or you should all, be very proud of that, and even more proud after today, hopefully. So I think
Yes.
that's fantastic.
Okay.
Yeah, so thank you, Brian, for igniting the teachers' enthusiasm, the opening our problem-solving skills, and yeah, right. Lego education. We need to inspire and develop the builders of tomorrow.
Exactly.
So we're very excited for today. So there's a lot of we have a speaker from Canada as well, Brian.
Exactly. We're welcoming Tim in a few minutes, who will take us through a virtual programming experience.
Yeah.
Yes.
So, but before that, let's invite Miss Mylene Abiba, the president and the CEO of Velta, to welcome also Brian and to have a short conversation about what transpired yesterday, and the experiences of the teachers, the comments, the feedback to share to us, Miss Mylene.
That we had yesterday.
Good morning.
Hello,
Oh, good
Ma'am
morning.
Eileen.
Hello, good morning. Yes,
Morning.
Good morning.
yes, thank you so much, Brian, for waking up very, very early again.
Yeah.
We're actually working on three time zones: the Philippines, Denmark, and Canada. And we really appreciate, in behalf of the Filipino people, we really appreciate all the efforts and sacrifices that all our speakers have given us. Thank you so much for from the Filipino educators, the parents, and the learners. All right.
Yeah.
Well, I just want to give a point just to segue on what we're going to be doing today. We live in a very interesting times, uncertain times actually. But the only
Yeah.
thing certain is that technology will be the growth driver in of the future of any recovery or growth of any country in the world, including Denmark and
Exactly.
Canada. So that's the
Mhm.
reason why we are actually doing this webinar, so that we can equip our educators, our parents, and our learners to have the key role in being critical thinkers, to have a science literacy, and also to be the next generation innovators. So these are the key elements that we are looking into. how we can contribute in the growth and recovery of all our nations. Now, education is very crucial, and even if we are in our homes, or that we are in our blended mode in our modality of teaching, we need to make sure that our learners are relevant when we are finished with all this pandemic, and we go back to the face to face or our new norm in education. So my last message is that let us win the future. Our learners are the key to the future. We have to make sure that they are relevant after all the sacrifices we have made in homestay, in home learning, blended learning. But we make sure that when we are over this, over the hump, we have to win the future, and we have to win as one Philippines. So, with that, I'd like to just welcome you to this virtual experience, and that I assure you, for one, that it is going to be again another hard fun. Well, there were so much traffic yesterday trying to download. Yes,
Yeah.
we had 200,000 viewers. I guess I see half of them probably are trying to download, but please just be patient. You will get your licenses, and
Yay!
then Cognation Robotics will also give some good news about uh, their extension of the license, because that is, of course, there's a certain cost for that, but because they're so generous for the Filipino educators and the parents, that they have extended the free trial license up to December of this year. Yay! So
Yay!
Yeah.
yeah. And
Wow.
before I turn you over to our webinar proper, I'd like to also announce that these are the items that will be for raffle later. All right, so this is the Lego education notebook, and then you have the, I don't know if you can see. Okay, this is,
Wow.
yeah, the
Good.
Wow!
tray.
Cute!
There you go. There you go.
Wow.
And then you have, yes, a name card holder, a Lego card holder. Yes, these are all. Yes, these are all.
Wow!
Yes, and of course, yes, your Lego key ring. Yes, so these are all up for
Cute!
raffle later. So what you
Love it.
need to
Love it.
submit is in the chat group is your name, your school name, and your mobile number. So it's easy for
All
us
right.
to contact you and get your details. So with that, I'd like to welcome again all our educators, our parents, and our learners. Again, I would say we win as one. We will win the future. Thank you very much. God bless.
Thank you,
Yes.
Miss Mylene.
Thank you, Miss
Thank you.
Yeah.
Mylene.
Thank you, Brian. We'll see you later for the
Yes.
question and answer, and I hope you're good. And we're very happy that you're here again, Brian. We like to express our appreciation for your time. I know it's early in the morning, so the Filipinos will really love you for that for that effort. Thank you so much.
Thank you,
Thank
thank
you.
you.
All right, Miss Joy. So yesterday,
Ayan.
how's your project?
Um, I'm a member of Team Replay, and I created my doc yesterday. Actually, it is almost the same with the keychain of Miss Mylene.
Oh, great, awesome.
Oh yeah, because my favorite color is blue. That's why I have this feeling that I will win the raffle later. Joke.
Yes. So
Okay.
also, I had the also. It's hard, really hard learning because when I tried to build my robots, the software that I was using was actually the tools were incomplete. So when I chat and asked Ma'am Annalyn, she assisted me, and she told me that I have to try the lower version. So I downloaded the lower version of the Lego Digital Designer, and with that, I was
Mm-hmm.
able to build my robot. But it's still difficult. But as mentioned, it's really will twist your brain, but at the end of the day, it will be worth it when you already build your own robot. So later we will follow that.
All right. So
Yes, Miss
actually,
Joy.
some of the teachers also experience that. Um, they cannot find some parts that has been mentioned by Mom Annalyn yesterday. But I think Ma'am Annalyn already answered those questions at the comments yesterday,
Yes.
and she gave us the link.
Yeah.
Yeah, so that um one technique that I did is that the power of share box. What to call that? If ever I will look for some parts, I will just type there at the search box. For example, flat. So the bricks will follow. Then for example, it's 2 by 4. I just type
Yes.
there at search box, and then that's it. I can now
Yes.
find the part.
Yes,
Just
Miss Joy. So it's good to have that team replay, and
yes,
that's the webinar is recorded, so we can
member.
check and follow it again. So again, our
Yes.
outputs, it will be posted in our learning management system. So that's
Mm-hmm.
in our training .ph. So you
Yes.
will have to paste the folder or a link from a shared folder for your
Mm-hmm.
outputs. But it's good that they are sharing it in our Facebook page because
Yes.
everybody can see it. It's like, well, I'm very proud of my work.
Correct. The teachers are having so fun in creating their first Lego duck yesterday.
Yeah, so with that, so I think everybody's excited for today's session. So before that, let's have a short video.
Yeah. Okay.
All right, Miss Joy. So again, we're very excited to have our speaker. So let me introduce our speaker, Miss Joy.
Okay, go sir.
So yep. So our speaker is the Director of Business Development of Cognition Robotics. For almost 10 years, you have been working with educators worldwide to understand what product features and functionality were needed to enable widespread use of digital robotics in the classrooms. Combined with correlating these requirements with the business needs of distribution and development partners, Cognation was able to establish a virtual robotics ecosystem for both education and competitions. He has been in 30 years in the IT business with major companies such as Hewlett Packard and Sun Microsystems. in enterprise computing systems. Much of this time was spent interfacing with large corporate customers and building partnerships with application providers to develop and support solutions for their requirements. Married with 4 children and 3 grandchildren, all of 4 whom are involved in IT or science and technology careers, hence the significant interest in promoting STEM education for all. Let us all welcome to share to us how to teach STEM education through virtual robotics, the Director for Business Development, Cognition Robotics Canada, Mr. Tim Shea. Good morning, Mr. Tim.
Yay!
Good morning. Thank you very much for that introduction. And I really appreciate the opportunity to be able to meet with so many people, so many interesting people who are driven to try and do the things that we really need to do to bring the world forward here. Just as a quick introduction to add to things, as you can see, I'm an older fellow here. I've been in the business, the IT business, for a long time now. And if there's one thing that's always constant in our business, is that things are changing and new things are being added all the time. And if anything, now the pace of that change is accelerating. None of what's going on in the current technology businesses are about to go away, but there are so many new things that are being added constantly. And what I wanted to talk to you, or what I was asked to talk to you about a little bit today, is how the use of digital and physical, particularly in the use of educational robotics, is really going to be, or should be, mainstream to teaching all our kids now moving forward. So we have some slides prepared. So if we can start to show them, and we can get into the presentation part. Okay, and again, that's just our quick introduction. If we can go to the first slide. Okay, careers of the future. What's happening now, and is a sea change in how work is being done. If we look at the screen here and we talk about autonomous cars, smart cities, robots for assisted living, and the increased use of distance learning, just a few years ago, none of these things were important. None of them were mainstream use of technology, but they all are now. I had the good fortune to be at the Consumer Electronics Show in Las Vegas earlier this year. And while many people think of it as a show for consumer electronics, I would say 40% of the entire show, and it is a huge show, was talking about business applications for computing. Again, talking about the autonomous cars and the smart cities. That is where the careers of the future are going to be. This is what our kids need to start learning. I've often posed the question to some of the presentations that we're giving. What is the conceptually at a high level? What's the difference between $100,000 autonomous Tesla car and a much less expensive Lego Mindstorms robot? And the answer comes back, as people do understand it, that conceptually there really isn't much of a difference. The autonomous cars obviously cost a lot more money. They're a lot bigger, but they rely on the same basic technologies that the Mindstorms robot does. The being able to take in information from sensors, being able to understand what to do with that, sending that information back out to the motors and actuators and whatnot. It's exactly the same process that's involved in building not just autonomous cars, but if you're trying to run the water and power systems of a city, if you are designing robots for assisted living, all the technologies are merging together. And that's why our kids need to learn to be able to merge the worlds of digital and physical assets together to be able to succeed in the world coming up. So with keeping, say, these four particular technologies or areas of interest in mind, we want to understand where we need to move forward now and how these can be merged together. Okay. All of these things, right? Again, the cars, the cities and whatnot are built upon a few major foundations. Okay, one of which, of course, is the use of artificial intelligence, which everybody is excited about. And again, by the use of people being able to understand the robots and how to program them, you are learning the basic building blocks to creating artificial intelligence applications. Very important things. The whole of smart cities and a big part of automated cars, autonomous cars, is learning about the Internet of Things. And when I talk about changes, as I did a minute ago in the IT business, these kinds of things never existed a few years ago. To be able to connect everything up in a worldwide web to be able to control all kinds of things through the internet. That's just amazing. And that's only in the last few years. Our kids, the kids that you're teaching these days, are coming to expect that. That's just normal for them. To us, it's something that's new and interesting, but we need to build on that with them. And with that, of course, goes into the data collection, right? Being able to use the sensors, just as you do in a Lego Mindstorms robot. What action you have to take. Use your problem-solving skills to understand what needs to be done, and then build on your coding skills to be able to send that information back out to the robot to be able to accomplish the tasks that you have decided it needs to do. All those skills that you're teaching these kids now in both a digital and physical way with virtual robots and the real physical robots, those are exactly the same skill sets that kids need for all those future careers that we just talked about. All right. And what are all these things built with? If you're trying to build an application for assisted living, if you're trying to build an application using artificial intelligence, you basically need the same kinds of skills, right? You have to have creative skill sets to solve problems and think outside the box. Most of these careers and solving these problems are going to be done by kids who can understand that you've got to be able to not just follow directions, but step outside of that. Brian, in 15 minutes ago, talked about he hoped that some of you had failures yesterday in what you were trying to do. And nothing could be really more important than that. You've got to be able to step outside your comfort zone and learn and try and understand things. And that involves doing things that sometimes don't work. And that's fine. And kids need to understand that that's okay to fail. It's not a bad thing. That's how you learn. That's how you build things to be able to create and new applications. And that's how everything in the world moves forward in technology, by people who aren't scared to try different things and risk failure. Failure is okay. You got to learn from it and move forward from it. Right? And another big part of what we're trying to do with our virtual product, right, is develop the teamwork and communication skills that you need. None of these applications are built in a vacuum. Kids and workers around the world need to be able to work together. And again, what has changed in the world in the last little while is that it's so important now to communicate across time zones. Mylene has talked about, we have people from Denmark, Canada, and the Philippines on this call. Well, those are becoming commonplace as companies and governments are trying to find skill and expertise wherever they can find it. If they have to rely on people in a different continent and a different time zone, that's fine. It's the skill sets that are important, and being able to have the teamwork and communication skills are really important. One of the things we've always talked about when we got into this business and really started to work with the Lego Mindstorms robot is that one of the things the fundamental things that we've always kept in mind and always talked about is that we were trying to design a virtual experience to enhance the Mindstorms experience. We don't in any way want to replace the physical robots. That kind of learning experience is critical, but we also think that the digital skills moving forward combined with that are vitally important for all these new careers that we just talked about. Okay, so where do you get those skills from? How do you learn the kind of skills that are going to be important for these careers of the future? Well, we've thought for a long time now, when we first got exposed to it, that by the use of the robots, which again, fundamentally have the same concept of autonomous cars, of smart cities, playing with the robots, robot-based curriculum, and competing with the robots are how kids get motivated to learn those skills. Okay. We've often said if you're trying to get a 14 or 15-year-old boy or girl excited about learning to code and learning these kinds of skills, do you want to do that by maybe having them work on a payroll application for your local municipal government or telco? That's not terribly exciting for them. But what if they're competing with robots, with other kids around the world, and they can play football games against each other? They can have sumo games. They can have contests that they get excited about competing and playing and learning. But all at the same time, they're learning the exact same skills that are required for all these careers of the future that we talked about. Right? They go hand in hand together. And that's why when we first got into this business of trying to virtualize the robot experience, the Lego Mindstorm robot is a perfect vehicle for teaching kids all of these skills. But again, we think from our point of view that the merging of the digital and physical are a very important part of this. Okay, we actually have a quote here now that we got from Microsoft, and actually the president of Microsoft Education. that, and because we have always talked, or when we first got into this business, and when we were talking to Lego directly in Billund, we always talked about our digital virtual robots and the physical robots as if they were two very different things, right? And now what Microsoft is saying, and this spoke, it was as if he was speaking directly to me, is that kids today are unable or unwilling to draw a distinction between a physical asset or digital asset and its physical equivalent. So what this really means is when they see a physical piece of equipment, when they see a physical Mindstorms robot, it is that they are expecting now that there be a digital equivalent for it. They are looking to be able to have a virtual experience where that they can communicate and share with other kids around the world, to be able to do things in a digital world that they can then bring to the physical world. And that's what we've been trying to promote, that we want kids to be able to, when they're at home and don't have access to a physical Mindstorms robot, they can still be learning the exact same programming skills. They can put together the code that they want, go through various iterations of it, and then when they get it the way they want it, they can come back to school and just with a click of a different button, they drop that code onto the physical robot and see how it works. Right? So virtual robotics are proven to be a positive vehicle for education and teaching 21st century skills. Right? And if any of you are interested in seeing, we have had research studies done, not by us, but by independent third parties, that talk about the efficacy, the educational value of having both digital and physical robots together. And they have shown very clearly that the use of the two technologies together, digital and physical, is actually the best way for kids to learn, right? Not just digital, not just physical, but having them together. Okay. And we have shown from what we've been doing now, literally around the world, that by using simulation technology, we can get more people in more places, all right, engaged in learning with robotics at a fraction of the price of working with the physical hardware. So again, we don't ever want to replace and aren't trying to replace Mindstorms robots, but we want to get more people involved in the experience. And we can very much, we are very confident now and have proven that we can do that around the world by using the virtual robotics toolkit in combination with the Lego Mindstorm robots, right? And again, getting kids up to speed on 21st century skills. Okay, so one of the things we wanted to talk to you about was a real life case study that we have been very intensely involved in. And that involves one of the world's, if not the world's largest manufacturers of physical items, and that is Boeing. Okay. And it's important to understand that Boeing, of course, has so many different arms and so many different things involved with that company. And yet, when we tell you what they're doing right now and how this relates exactly to what we're talking to you about you doing in your classrooms, you will see why we think it's important that these skills be merged together. Okay. Boeing, of course, has many integrated processes, right? From requirements analysis to product design, and then from design to testing, and then from test to production planning, and then from planning to the shop floor. And they have understood in the last little while that this can be a very complex process. They have certainly had some issues in their engineering departments, which is no secret around the world. And they are working very hard to make this a much more seamless and better process for their company. So what we have engaged with them about is working together with what they call model-based engineering, where they are trying to merge the digital with the physical. So they want their engineering groups to be much more involved with having a digital asset that they are working with and have its physical equivalent so that they can move back and forth between them. And they understand that their engineering groups can get a much more efficient use of their very expensive time and expertise by having their people work together. And again, they can work around the world in groups that are physically distanced, but they can still work together if they are working with digital assets. But it's important for them, and they call the process, and we've heard this from other companies as well, they call this process digital twinning. And they want to get to the point where within their company, that for every physical asset that they are working with, right, whether it's a jet engine or whether it's the door to a plane or whether it's a wing design, all of those physical assets will have a digital component. And so they want to be able to take from digital concepts and designs to physical processes. And you may have thought that this was something that a large company like Boeing was already doing, and they were in small parts, but they did not have this as a company-wide mantra. And they are now trying to expose this throughout their organization. Okay, and again, so what they're talking about again is being able to twin everything that they're doing and they are now in a process of teaching their engineering staff how to do that, right? How to work with various models and be able to maintain the discipline and the rigor to go from the physical to the digital. Right? And what they hit upon, and why they approached us in the first place, is that they are now training their senior engineering staff. And we actually did this last fall with them. Priyanka, my partner on this presentation, flew to Seattle with another one of our people, and were part of a week-long training class with senior engineering staff at Boeing, working with physical Mindstorm robots that we actually bought for them and brought to Seattle with us, all right, and our virtual simulation, so that their design engineers were building designs digitally and then building the physical asset, the physical Mindstorms robot, based on the virtual designs that they were building. And this is literally the exact process that they're wanting to use with their $100 million, much more expensive than that, airplanes. And they are, interestingly enough, again, using Mindstorm robots and our software to be able to show their staff how this digital twinning concept works. And so we're here to tell you that not only have we run that course back last fall, but they want to run this as a process moving forward with all of their engineering staff over the next 2 to 3 years. Again, working with the physical robots and the simulated software. And this is going to be something that's going to be more prevalent moving forward. We have had some preliminary discussions very early, so we can't really talk about it, with a major automobile manufacturer based in Europe for doing exactly the same type of training. And again, they are very interested because, of course, autonomous cars are a significantly potential part. Where they're going to get the skill sets for their employees moving forward is from people like you teaching the kids today how to do these things together, how to build things in a digital world that correlate exactly to what the physical models have and move back and forth seamlessly between them. And the benefits of design, the benefits of efficiency, the benefits from a cost analysis are huge by being able to combine them and do this model-based engineering. Right, so that's why we are so passionate about being able to work with people like Mylene and your groups to be able to talk about this and what actual real companies are doing right now throughout the world and moving forward to do this. So we would love to be able to work with your people moving forward. We again think that this is where the world is going. The future is absolutely going to be working with sensors, working with coding, working with programming, and combining the digital and the physical assets. Okay, so thank you for your time. We certainly want to work with you in the future moving forward. We would love to have a close working relationship with Lego as well. And moving forward and helping to teach the kids. As Mylene mentioned, we will be offering copies of our software to get your teachers and kids excited about this. We stand ready to help with training and being able to put programs together. There are companies around the world and individuals around the world who are developing very interesting curriculum, training classes, and more importantly, from our point of view, really interesting games and challenges for kids to get excited about learning. And so we would love to expose you to all of those things as well moving forward. So again, thank you very much for your time, and we appreciate the opportunity, and hopefully we'll chat again. Thank you.
Hello.
May we introduce Priyanka Tuteha. She is the head of operations of Cognation Robotics. Now, she will be handling all the technical, I would say, logistics that we will be encountering because as I mentioned a while ago, there are a lot of educators already downloading the VRT, and she will be assisting us. Priyanka, can you share with us some tricks and tips for the teachers, for the educators, and the parents? Yeah.
Well, hi
Hello.
everyone. My name is Priyanka. Thank you so much for the introduction, Mylene. Um, well, some tricks ready for failures. But jokes apart, the first trick is if you have any questions or concerns, feel free to contact us anytime at support@cognition.com. And then there's also Mylene's team who can assist you. Um, once you are in there and once you spend a little bit of time with VRT, you'll get like really accustomed to it. And then once you're into it, I promise you'll not get bored. You'll have a real good time. As Mylene already introduced and mentioned it a little bit, we have decided to extend the trial of the software till December 2020. I think we'll be synchronizing with Felta Multimedia to provide you access to the license keys. So you will be able to access VRT till December 2020 without any cost associated.
That's great. That
Wow.
deserves a warm applause. Nako, pag tinignan nyo magkano yan.
Yay.
Yes, thank you so
Thank
much.
you.
So the educators are our frontliners. They're really
Agree.
our frontliners, and this is
Yes.
really a very fantastic gift from Cognition Robotics and the Canadian government, I would say. That, thank you so much. Yes, because with Felta Multimedia assisting the educators and the parents, I believe that our goal to really engage the learners, even in a homestay environment, and also offering them virtual competitions. As we later on we will mention that the Philippines was the first to roll out the first virtual competition in I think in the
In the
world.
world. Mhm.
Yes, in the
Wow.
world during the start of the COVID quarantine. So we're very happy that the trust and confidence of Cognition Robotics has been given to Felta and our team. And later on, we're happy to show you that we have a learner from the DepEd Manila who will be only at 11 years old. He will be
Wow.
showing us, yes, only at 11 years old, he will be showing us how he was able to learn virtual robotics, particularly programming. And he was one of our winners in the first Philippine virtual robotics competition. So later on, we will introduce the little boy. Yeah, so we have a lot coming up for us. And as Tim has mentioned, that the future really is going to be a bridge between technology, digital, and the physical world. So we're very fortunate that we have this virtual webinar, this live webinar with our partners, and we will, as Priyanka said, just don't give up. As
Yes.
any technology, we know that the first step, like walking in the moon, walking on the moon is the first step is very difficult. But as I said, hard fun and learning by
Hard fun.
making. Yes, and learning by making. So kaya-kaya natin to. Okay, so I
Yes, we
think
can do it.
Bianca and Tim will be staying on for the questions and answers at the latter part. It's not too late in Canadian time, right? So
No, we're
Yeah,
good.
we're fine.
thank you so much
Yay.
for staying up with us. So I think we can move
Yep.
on for the actual training proper with a video, with the information video. Thank you.
Okay.
See you later.
Thank you. Thank you, Tim. Thank you, Priyanka. See you later.
All right.
All right. So, Miss Joy, so I know everybody is very excited now to proceed to our hands-on session. And but before that, let me have a feedback or a comment lang for earlier talk. So Tim was really able to share to us not just about the future careers of the future, about the virtual robotics as a proven positive vehicle for teaching 21st century skills, but also I'm glad that he was able to share some a case study about Boeing,
Mm,
so that even our parents can reflect and know that, oh, the industry are also using robotics. So they use modeling, they use simulation. So using
mhm.
robotics is not just for design or just for play, but
Play.
in the future, it could be a career of their kids, their future career.
Especially if the children was taught with the programming, their critical thinking skills will be developed, and they can apply this to um, education, industries, and having fun at the same time. Diba? For
Yes,
me,
and we
that's
would
very
like to
important.
we really encourage our parents and our learners to really jump in and learn robotics. So let's with that, let's welcome again our trainer. She's a Lego Education Academy trainer, a Felta TechVoc Academy Master Robotics trainer. A virtual applause to teacher Annalyn Aban. Good morning.
Morning,
All
teacher
right. Good
Annalie.
morning, everyone. Good
Morning.
morning.
So how are you?
Medyo, sir, medyo hindi nakatulog sa daming PMs about the application. But then I was feeling great kasi po we are really into helping yung mga porsigido talagang matuto. We're
Yes.
very happy to assist those kind of inquiries. And we're very happy na at this moment po, marami pa rin nagbe-message yung sa applications na gagamitin. Ngayon po, for those teachers po who are still trying to get the application, you'll be sending po the downgraded link for your reference. You don't need to worry naman po and to be stressed kung wala pa po kayong robot. Kasi po, as Sir Mark mentioned, you can post your creation through LMS. So technically, hindi nyo po kailangan matapos today. Kaya po
Mhm.
half-day sessions lang tayo so you can have the afternoon session for you to explore and review all the learnings that we get from the seminar. As Sir Brian
Yeah.
Dam mentioned po, failure is part of the learning process. So wag po tayong panghinaan ng loob kung pag-download pa lang hindi na natin magawa because when we encounter failure during the process, it will
Mhm.
lead us to become more persistent in doing things.
Yes.
Ang kailangan lang po
Exactly.
natin, consistency in order for us to get the whole crop accordingly. Alright? So, thank you for all the good comments doon sa ating topic tomorrow. Kung na-stress po kayo pag-download ng application this time po, mas challenging ang ating topic. Our
Kala ko mas
content will
stress.
be more on the simulation application and more on the software. So technically, we'll do programming. Okay, kaya po maganda na po ng kape, ng
Mas
biskwit, at
mahabang pasensya.
cooking, at mahabang pasensya for you to become energized for this topic. All right. Thank you.
Thank you, teacher Annalyn. Take it away.
Go, ma'am.
All right. All right. One of our IT technical team will be on the live chat po sa ating YouTube for your inquiry. Okay? And we'll be sharing as well yung mga application needed po for today's training. So for today's training po, what you need to prepare is the BRT application. We'll be giving you the pre-license. What you just need to do is to download it. And then together with the virtual application software, you need to download as well the EB3 Lab programming software. For that is the environment wherein we gonna do programming in order for us to simulate our robot. Okay, now let me share with you my slide. All right, there you go. So there is a new robot in class. Okay, so what I'm going to introduce at this moment is the Lego Mindstorms EV3 Education Robot. So we'll have first the introductions of Lego Mindstorms EV3 education. Yesterday, we already introduced what are the different terms that we should understand in studying robotics technology. We also discussed yesterday the different types of robot. As we mentioned, we have educational robotics that we are using with our education program. So technically, we'll be showing you one of the sample robots that we are using for our robotics courses, which is the Lego Mindstorm set. Now, since that we are in partnership with Lego Education, for you to understand more, let's define of what is Lego. The Lego is derived from the first two letters of the Danish word leggout, meaning to play well. Learning through play is a term used in education and psychology to describe how a child can learn to make sense of the world around them. Okay, through play, children can develop social and cognitive skills. So in Lego education, what we are promoting is learning through play for the 21st century learners. Now let's try to identify of what is a Lego robotics. Lego robotics is a body of teaching and learning practice. It was based on Lego robotics kits, a popular set of materials that enable individuals without formal training in engineering and computer programming to design, to build, and program small-scale robot. So you don't need to worry if you are not into computer skills, because as I mentioned, this is a learning practice. So even if that you are not an engineer or a computer programming graduates, technically you can learn this Lego robotics that we can use for our education program. For things that we will be doing here is we will just simply design, we will simply build and program only small scale robots that we will be using for prototyping. Now, the thing is, why do we need robotics in education program? So, with this robotics education program, technically it will lead us for emotional engagement. As I mentioned, we are promoting learning through play. And then interaction with physical devices. So that would tackle the cognitive skills that we can get from having this robotics program. And then learning by doing things, multidisciplinary learning and constructivist approach. Those are the pedagogy that we already discussed yesterday. Now, what would be the advantage of using this Lego Mindstorms educational set? Using this set, our student will have a previous experience with Lego bricks. So most of our students nowadays are already into Lego. So that would be additional points for all of our students. And then another good thing or another advantage of using this Lego Mindstorms, it has a robust software and a hardware. So the thing is, we will connect through our daily lesson in STEM. And then right after that, right after we connect, we will let the student explore through building and exploration. And then right afterwards, there is a software wherein we can explore coding and programming in order for us to do testing. All right. Another advantage is it is a good trade-off between complexity and possibility. Now, what would be the benefits of using Lego robotics? Robotics is a concrete and a tangible way to build and strengthen cognitive development. as well as other academic areas such as mathematics, engineering, communication skills, strategic thinking, and goal oriented thinking. So in science, okay, we will design and program a programmable robot using motors, sensors, gears, wheels, axles, and other technical components. Under technology, it will lead us to understand and interpret two-dimensional drawings to create three-dimensional models. What are those? Build, test, troubleshoot, and then revise design to improve robot performance. For engineering, brainstorm solutions. Choose one, build it, test it, and evaluate. All right? And then for mathematics, technically you will gain a practical, hands-on experience using mathematical concept such as estimating and measuring distance, time, speed, and with this, we can communicate effectively using scientific and technical language. As what we have with our demonstration yesterday in using a color sensor, we'll be using a lot of mathematical skills and formula in order for us to run the given robot. Now, let's discuss the overview of Lego Education Mindstorms. At this moment, I'm trying to inject the DNA of Lego Mindstorms robotics set. All right? So we started having this robotics program since 1986. Okay, the first computer-controlled Lego product are released, and that is the first generation of our robotic set that we have. We call that Remote Control Explorer. Okay, so that is our RCX. So as you can see, we also have here ports for motors and sensor. Okay. So that is the first generation. Now let me show you the different models that we can come up with this RCX robotic sets. Right, there you go. And then, right after 2 years, in 1988, okay, we already have the second generation Mindstorms NXT. Could you imagine, right after 2 years, from 1986 to 1988, the collaboration between the LEGO Group and the Massachusetts Institute of Technology begins on the development of an intelligent brick that will bring LEGO creation to life via computer programming. As I mentioned yesterday, using this LEGO Mindstorm set, okay, Lego Group come up with a comprehensive research on how we gonna interconnect this with our STEM curriculum. So these are the sample robot that we can, okay, so these are the electronic components that we have with the second generations robot. I know some of you are a bit familiar with the electronic components. For this is one of the materials that we use in Lego Digital Designer hands-on activity. So as you can see, we have here the brain of the robot at the middle. That's the number one. Okay, we call that intelligent brick that serves as the brain of the robot. And we discussed as well from the demonstration yesterday that we have their buttons in order for us to navigate files that we will be transferring to the brain of the robot. And then we discussed as well that we have the input ports and output ports. So on the upper part of the intelligent brick, we have there the servo motors that is connected with the motor output ports. And then on the lower part, as you can see, we have their different electronic components. So what are those sensors that we have? We have the touch sensor, we have the sound sensor, meaning we can command our robot through sounds. We have there the light sensor, and we have there the ultrasonic sensor that serves as the eye of the robot. And these are the sample robots that we can come up with the second generation set of robot. Right, there you go. And then we are very lucky for here in the Philippines, we are already using the latest generations of Mindstorm set. Okay, so the third generation called Lego EB3 core set. Right? So this is the educational set and the latest generation. EB3, okay, refers to evolution 3, okay? Stating from the fact that this is the third generation of the Mindstorm kits line. Okay, Lego EB3 contains software and hardware to create customizable and programmable robots. It will help the student to build, program, and command their own kind of robot. Right, so EB3 is the third generation. Lego Mindstorms EB3 is the third generation robotics kit in Lego Mindstorms line, and it is the successor to the second generation, which is Lego Mindstorms NXT 2.0 kit. The EV designation refers to the evolution of Mindstorms product line, and again, 3 refers to the fact that it is the third generation of computer modules. Okay, this education edition was released last August 1, 2013. Okay, so that is the whole core set. Okay, as you can see, it comes with a sturdy box that comes up with a sorting tray, that comes with electronic components and technical structure terms that we can use for the design of the robot. It also comes with expansion set if we wish to create more more designs, more comprehensive designs. All right, so yesterday some of you are having hard time in in getting some pieces. Okay, at this moment, I'm going to show you the different Lego Technic building systems that we are using, okay, for building and creating designs. So we have structure elements, we have movements elements, we have connector elements, and we also have decorative elements. And then right afterwards, we have motors and sensors. So technically, we are using this motor and sensors for controlling inputs and outputs. Then it also contains ball wheel, connecting cables, building instruction, and EB3 software that comes nearly with 540 Lego building elements such as beams, axles, gears, and pin. Okay, this can be used in exploring creativity, building, programming, and critical thinking skills to provide solution to a given scenario. The kit is an excellent learning tool to communicate, collaborate idea, test creativity, and to become young engineers and problem solvers. Right, so we have their beams, gears, wheels, and axle pins, and axle connectors and decorative elements. So this is how we measure beams. So we repair by counting the number of holes. And please take note that beams comes in odd numbers when counting the hole, and with one exception, start from 15 and go down to a single even number beams with 2 holes. So these are different available sizes. I think this would be very helpful for your LDD application. We have 3M. M is equivalent to modules. Those are the holes that we have in the beam. We have 3M, 5M, 7M, 9M, 11M beam, 13M beam, and 15 modules beam. Please take note that the number of holes correspond to the length of the beam in fundamental Lego units or the modules as equivalent to 8 millimeter. So tips for determining the beam size. To quickly determine the size of the longer beams, simply place the finger on the middle hole of the beam. Then right afterwards, you can quickly count how many holes are on one side. And then right afterwards, you can you can you can double it and then add one to simply get the numbers. So as you can see from the left side, we have 5 holes. And then on the other right side, we also have 5 holes. Added into 2, that's 10, plus the 1 modules at the middle. So definitely the size would be 11. Then I think some of you used this angular beams yesterday. So why I am discussing these EV3 elements for you to easily search on the pieces that you need in building and creating your robots. So for beams angular, we have angular beam with 3 holes before. Okay, that is a 3x7 angular beam. We also have 3x90 angular beam that holes that comes with ends. 2x4 by 90-degree angular beam has a hole at one end and cross hole at the other. Then all the other regular beams has cross holes at the ends. So this is the angular beam 4x2 by 90 degree. We also have angular beam 3x5 by 90 degree, angular beam 3x7, angular 4x4 beam, double angular beam 3x7, and T-beam 3x3 with hole. Then we also have pins and axle pins. So for pins are like the nails and screw bolt. Okay, so we have 2 types. We have the pins and axle pins that comes with friction, and pins and axle pin under non-friction. So technically, these friction pins are very important in order for us to achieve the stability of our robot. So in building robots, there are 2 goals. Okay, to to make movements and to make stability. All right. So if you wish to create movements, technically you'll be using friction pins. And if you wish to create stability, okay, we have there the non-friction pin. Then we also have here beams and fin combinations. So beams and the snobs. The snobs are the connectors. Okay, we usually use this to connect our robots to make it more stable. Then we also have frames. Then we have thin beams. We have axles and connectors. Then we have specialty axles as well. As you can see, we use this axle connectors in order for us to connect yesterday our motors and in order for us to connect our motors to the intelligent brake. Then we have bushings that we use for locks and for stability. Then we have cross blocks, axle connectors, gears. So those are the different types of gears that we have. And then the thing that is most important thing that you need to consider if you wish to execute movement is the combination of gears. So for your reference, we'll be sending this link for your reference in trying to create combinations. So there are stable combination, unstable combination, and unknown combination as well. And we have the tires, rims, and tracks. We have cable wires for connectors. Then we also have download cable wire and decorative elements as well. All right. Now, for you to appreciate more those pieces that we showed for your reference for your LDD concept of design, we'll be showing you an actual demonstration. All right. Okay, just for a moment. Right. There you go. I have here my actual robots with me. So this is the alcohol dispenser. Please stay here for a while. Okay. So I have here the actual box. Okay. This is the whole corset. Let's set this aside. I have here the whole box with me. Okay. And then the good thing about with the box, it comes with a sorting tray wherein we can sort all the pieces, all the technical structure that we can that we'll be using for building. So this is the PIM. That's what I'm discussing a while ago. Okay. And then here are the angular beams. Then on this side, we have there different designs and sizes of gears. Okay. Right, there you go. So we have different sizes of gears. We have here sets of beams. Okay. Then we have here the pins connector. We have here axles. It comes with different sizes as well. And we have here frames. And then under the tray are the different electronic components. Okay. So as you can see, we have here the intelligent brick that serves as the brain of the robot. Then it also comes with the large motor that is in charge for movements. All right. Then we have here a medium motor. Okay, we usually use this for the extra movements of the robot. Then it also comes with different sensors. We have here the ultrasonic sensor, right, that serves as the eye of the robot, and it can see up to 220 centimeter. Okay. Then we also have here the gyro sensor in order for us to measure the angle of the robot. Then we also have here the touch sensor. Then we also have here the color sensor that can see up to 7 different colors, right? And the thing about with the box, okay, we have here the inventory at the box. So we have the reference of what are the pieces that we have inside the box. Okay. So let's set aside this box first before we have the actual demonstration. Okay. Then I have here the actual design. We call this design an educator robot. So this is the brain. Okay, we have here the controllers. We have here the display for us to see the navigation. And then it comes with the motor that is in charge for the movements. It comes with wheels that is connected to the servo motors. Plus it also comes with sensors. So this is the ultrasonic sensor that serves as the eye of the robot. Okay, we have here the color sensor. As I mentioned, it can see up to 7 different colors, and we can use this for 3 different modes: detection of color, reflected light, and ambient light. All right. So we have another color here for the line tracing. All right. For the demonstration, I mentioned yesterday that it can actually do basic movements up to comprehensive tasks. Right, so let's have first the detection of color. Just for a moment. Closer. Camera, Teacher Loria. Okay. So at this point, okay, we will be using the cuboid. And as you can see, this cuboid comes with different colors. So we will be using the color sensor in detecting colors. And then when it detects color, it will give us the command. Okay, I will set up first. Now, my robot will follow me according to the given command. Okay, so at this demonstration, we will be using the color sensor. Okay, so giving commands to the color sensor, we will be using our cuboid. So for my first command, my robot will move forward when it sees color red. So I'm gonna show this color. Okay, forward. So red is for forward. One more time. One more time. Right. And then color green is for backwards. Right? Again, let's redo. Color red for forward. And then, let's try color yellow. My command for color yellow is to make my robot turn right. And then, another command is color blue. When it see color blue, my robot will turn left. Okay, another one, right? Right. So, another thing, right? So, another thing that we can do is the functions of the ultrasonic sensor. Okay? So, with this ultrasonic sensor, I will make my robot follow my command. Okay, using a proportional ultrasonic code. Okay, just for a moment. All right. So the thing with this proportional ultrasonic command is my robot will continuously moving forward, and when it sees 15 centimeter okay from the wall, it will automatically stop. And then below 15 centimeter, the robot will move backward, and above 15 centimeter, it will move forward. Right? So let's try. Okay, so when my robot detects 15 centimeter from the wall, the robot automatically stop. And then below 15 centimeter, my robot will move backward. Okay, camera please. Below 15 centimeter. Below 15 centimeter. Okay, there you go. Below 15 centimeter. And then above 15 centimeter. Below, it will move backward. Above 15 centimeter. Below. All right. Above 15 centimeter and below 15 centimeter. All right. There you go. Let's go backward. Let's move backward. Move backward. And let's move forward. All right. All right. There you go. So that's the thing that we can use in creating our program. Next is, let me show you another functions of what we can have with ultrasonic sensor. As I mentioned, in regular robotics category game, for you to travel we are using reflected light. So for you to travel from start to finish, we need to do line tracing. And in order for you to do this, okay, you'll be using a lot of mathematical skills and formula, just like what we have in proportional demonstration. Okay, let's have the line tracing. Let's reposition our sensor. Okay. In robotics, since we are using mathematical formula, in order for you to execute this, you need to get the value of this surface, okay, and then the value of the darker surface, add it into 2 for mathematical formula, and then divide. So for if you get the correct formula, technically the robot will do the moving on this black line, right? Let's see if the given formula is correct. And there you go. And of course, we need to be safe. So after touching those robotic sets, we need to sanitize our hands using our alcohol EV3 sanitation. There you go. As you can see, with this alcohol dispenser, we are using the ultrasonic sensor. So my hands is now sanitized. So at this moment, we'll move forward with the highlights of this webinar, which is the virtual robotics toolkit. Okay, let's set this aside. So we're done with the elements. At this moment, we'll move forward with the virtual robotics toolkit. So it's a simulation application that we will be using in order for us to use it despite on a remote learning setup that we are experiencing at the moment. So what is virtual robotics toolkit? Okay, it is designed for use with the Lego Mindstorm's EV3 robot. The virtual robotics toolkit is a physics-enabled robotics simulator. The simulator allows user to drive their own virtual robot, but without the burden of ever needing space for testing or running out of physical bricks. So please take note of the following system requirement in order for us to use the simulator application. So for minimal device requirement, it should be IT and up. And then for ideal or beautiful simulation, please take note that it should comes with multi-core processor Intel i7. We'll be sending the links for the system requirements for your reference as well. Now, as we open the software, it will lead us to the default interface. So using this application, that's why we need to understand and consider the device requirement. For this application, we'll be using 3 environment. All right? The simulation environment, okay, and the learning environment, and the EB3 program environment. Okay? And then, for us to navigate the software, it's very important for us to understand the function of toolbars. So, as you can see, we have here 4 sets of icon bar. The first set is designed for file management in simulator control. So the first icon refers to simulation project window. That would be the first step. And then second is the start simulation. And then the third icon is to stop the simulation. Okay, well, I'm just, at the moment, I'm only presenting the functions of the toolbar icons. But then right after this, we'll have our software tour for actual exploration. Then for the second set of icons, okay, on the first icon, we have here the manage robot attachment. Okay, this is the icon bar wherein we can manage in adding electronic components to our virtual robot. Then next to that, next icon is the C scoreboard. So we have embedded challenges in the software application. We can actually use this scoreboard if we are planning to have our intersection or school or local and international events. Okay. Then we have here the EB3 virtual brick. Then for the third sets of icon, we have here the maximizing windows. Since we are using three learning resources or environment, it's very important for us to maximize the window. All right. First is the maximizing the EB3 programming environment. Second is in order for us to maximize the learning environment. And then the third windows is for us to maximize the virtual robotics toolkit simulation window. Okay, and then for the port sets, okay, we have here other opinions. Like for the first icon, we can use this to open the three window interface, the simulation window, the learning environment, and the EB3 programming environment. Then for the second icon bar, okay, we use that to open the two window interface. So usually we only use the simulation window and the EB3 programming environment. And then the third icon bar is to close the program. Now let's move forward with BRT software tour and exploration. All right. So upon opening the software, it will lead you to the three interface. Okay. So on my upper left side, we have there the virtual robotics toolkit simulation environment, wherein we can run and test the created robot. And then on the upper right side of my screen, okay, we have here the learning resources environment. Okay. And then on the lower part, we have here the EB3 lab programming environment. This is the area wherein we gonna do programming, okay, in order for us to test and run our virtual robot. Now, I discussed a while ago that it's very important for you to understand the functions of the toolbar in order for you to navigate the software accordingly. So these are the icons that we will use in order for us to navigate the application. All right? So in order for us to go inside, we'll be using the first icon bar, the startup icon bar. Right? Upon clicking it, it will lead you to the embedded activity that we have in the virtual robotics application. Right, so as you can see, we have here a different menu. We have here the sim basic challenges. We have here competitions. We have here first Lego League menu and WRO menu. All right, let's open all the teams. So for Sim Basic, we usually have this in order for us to understand the basic simulator, okay, by driving a robot in an empty room. All right. So technically, we are using Sim Basic. We are using Sim Basic in order for us to understand the basic concept of robot movements. All right? So what are the embedded activity under SimBasic? We have here a Sandbox EV3 in order for us to learn the basic of the simulator by driving a robot in an empty room. Another thing is we have here apartment cleanup activity. Okay, we're in with this activity, there are parts scattered all over the small apartment, and you can write a program to vacuum them all up. Then we have maze. Then we have cleanup challenge. We also have here sumo challenges. And we also have the soccer game. All right? So those are the embedded activity that we can enjoy under Sim Basic menu. The next to that is we have menu for competition. As we open, there is a blank area for the good thing about with this virtual robotics toolkit application. We can also create our own challenges that we can use with our classroom activity challenges. All right. Then we also have menu for first Lego League. For your information, for all the viewers' information, Telto Multimedia is the national organizer of World Robot Olympiad and first Lego League competition here in the Philippines. So as we open the first Lego League menu, we will see here the different challenges that we conduct on the previous year. So we have here the City Shaper Challenge. We have here Into Orbit Challenge. We have here hydrodynamic challenge. Then we have animal allies and more. For you to see the complete instruction for that certain task, what you just need to do is to click read more. Right? And then it will lead you to the complete game instruction and procedure on how you're gonna do such a challenge. Right, there you go. And then another good thing about with this is we also have theme for World Robot Olympiad. So as you can see, we have their different challenges. So in Philippine Robotics Olympiad, we have this category under a regular category game. So as you can see from the challenges, we have here the latest challenge for elementary category. Then we have here the 2020 Junior High School Challenge. We have here the 2020 High School Challenge. Okay, and the other previous challenges we can also use for practices purposes. And we can also embed this type of activity in our classroom application setup. All right? So the good thing about with this simulation application, we already have there the embedded virtual robotics and then the virtual game mat wherein we can run and test our robot. All right? Let's go back to the home page. All right, there you go. So for you to go back to the home page, you simply need to click the startup icon. Okay, for the demonstration and how we can use the virtual application, let's go to Sim Basic again. Okay, and let's open the Sandbox EB3 topic. So it requires project name. So let's say demo. Then press OK. And right afterwards, it will lead you to the simulation environment. All right, so as you can see, the good thing about with this simulation environment, we already have here the virtual robot that we can use for testing. And we have there the game mat wherein we can run and test our robot. Okay, for us to explore more the toolbar, okay, let's have some demonstration. So let's say that since that we already have the simulation environment wherein we can test and run our robot, at this moment we need to open the EB3 lab programming environment because that is the environment wherein we gonna do our coding. So from the toolbar, we need to click Windows, okay? The Windows setup for the virtual robotics simulation, the one I have here on the upper side. And then the other environment is the EB3 lab programming environment wherein we gonna do our coding. All right, let's say that we want the robot to move forward. Okay, at this time, let's focus first with the EB3 lab programming environment. So let's pick the EB3 lab environment only. Okay, so if you want to pick a certain environment for your activity, please rely to the toolbar. Okay, so this is the EB3 software that we will be using for our EB3 robotic set. Okay, for both physical and BRT robot. So as you can see, this software is very friendly. We have two versions. So we have versions for student and we have version for teachers, right? So the good thing about with this, it comes with a complete instruction on how you gonna use the software. So we have here the start here, the new project. It also comes with a tutorial. So as you can see, the good thing about with the tutorial, there are embedded videos on how you gonna execute that certain activity. So we have tutorial for basic hardware for the brick sounds. We have tutorial for the function of brick status light, brick display, brick buttons, large motors, medium motor, touch sensor, gyro sensor, color sensor light, and ultrasonic sensor. As you open one of this, okay, the good thing about this is it comes with a tutorial instruction and a sample program. All right, so as you can see, we have there the certain objective of this certain topic. And then as we go along, it comes with a tutorial video. Okay, and then we have here instruction for building. And then we have here interactive animation for the sample code. We have here an area wherein we can test it and we can also modify it. So going back to the lobby, we have tutorial for basic driving base. So these are the different topics that we can actually enjoy. Later, we can actually explore this after the lecture. Then we have tutorial for beyond basic driving base. All right, there you go. And we have here data logging, and we also have here tools. So all the necessary things and all the necessary information for you to the software is already embedded on it. All right. Then we also have building instruction for robot. So you don't need to worry if you are not engineer at hearts. So if we have the core set models, these are the sample robot that we can create. We have there the complete instruction for each robot design. Then if you have the expansion set models, these are the comprehensive design that you can come up with. Then this is the thing that you need to review and see. We have here the parts and the pieces. All right, there you go. So we have here the complete pieces of what are the things inside the box and what is the name of that particular pieces. For example, this one, EB3 brick, okay, and this is the code. And on its upper side, we have here an indication of how many pieces we should have. All right. So I think this survey elements is very helpful for you to easily create a robot design in LDD software. Let's go back. Then another special thing about what this software is, it comes with a curriculum. So we have curriculum and lesson for design engineer. These are the different topics. Robots in action, make it move, make it smarter, make a system, building idea, key concept, teacher's guide. Okay, so looking up on the teacher's guide area, we have here design engineering introduction, we have Lego element survey, and we have design engineering curriculum. The good thing about with the curriculum, okay, it comes with a complete instruction on how we gonna do a certain activity. All right. Then we also have curriculum for space challenge and science. Okay. So going back to the programming activity. So on the upper left side of the screen, at the moment we are staying here at the lobby. And then what we explore is the ultrasonic sensor. Now, let's say that we are ready to do our first program. Simply click add project. Okay, and then it will lead you to the working space wherein we gonna do programming. Now, please listen carefully. The white thingy on the screen is the working space wherein we gonna do programming. In EB3, the programming language is very easy and very simple. We are using here a graphical drag and drop coding. All right. So we have here the working space wherein we're gonna do programming. And then on the lower part, we have here the sets of palettes or sets of blocks that we will use in coding. So we have here different sets. First is the sets for actions. Okay. So as you open, okay, we have here palettes, or we can actually use this as blocks. So it's depend on the given task. Let's say that we want the robot to move forward. So technically, we have here, let me show you first the different blocks. First is we have the medium motor. So how to do code? It's very simple. You simply need to click it and drag it to the working space. So that's how we do coding. It's very simple. So the medium motor is usually used for the extra movement of a robot. Okay, as you can see, I have here my grabber and lifter that is connected to my medium motor. All right. Next is we have here the move steering block. Okay, this move steering block is for the function of the two large motors. This one, right? And then next to that, we also have here the single motor, the single large motor. So what would be the function of single large motor? So usually, we have here two connected motor in a basic robot that we gonna use. So I have here two motors, okay, that we usually use for basic movements of forward and backward. Now for turning, all right, for turning right and turning left, we usually use a single motor, okay, for beginners, right? But then next to that, we also have here the the move tank rather. Alright, so for the basic movements, these are the basic palette that we will be using. Alright, there you go. So what would be the difference of move steering and move tank? Okay, let me drag down so you can see. All right. Now let's try to configure first for you to compare and for you to understand. In programming skills, what you just need to do is simply configure. How? Under the palette, we have here different icons. The first icon bar is for us to indicate the mode of operation of our robot or our motor rather. So the first option is off. So technically, when you pick this, the robot will not move. Mode of operation on, infinite movement, continuous movement until the robot gets drained. And then we have here on per seconds. It can be on for degree and it can be on for a rotation. So as you can see from this configuration, there are different mode of operation on how we gonna control our motor. Okay, but then we wish the robot to move forward for let's say seconds. Okay, on per seconds. And then next icon bar refers to the direction of the robot. As you can see, my arrow is going up. So it refers to forward. Now, how we gonna control and change the direction? Oh, we gonna change it under the third icon, which is the motor power. Okay. So please take note for the control of movements, positive figures is equivalent to forward and negative figure is equivalent to backward. So for positive 0, it's going forward direction. And then when we change it to negative 50, automatically the arrows for the direction automatically change into backward. The arrow turns or goes down. Ibig sabihin po, we can control the direction through the motor power icon. All right? From the first icon bar, what we choose is to make our robot move for seconds. Now, how we gonna control of how many seconds, how many degree, or how many rotation? We can control that under port icon, right? So how to do it? Simply click, and then in my case, I want my robot to move forward for 2 seconds. Right, there you go. Now, going back to the first question, what would be the difference of move steering block to move tank? Okay? Going back to the move steering block, on the third icon, okay, we can see the motor power of our motors. While on the move tank, we have here both control for motor B and motor C. All right? Again, for move steering block, we have here a combination of motor B and motor C power. That is 50. While in move tank, we have both powers for motor B and motor C. All right? Now, let's say that we wish to delete those uh, unnecessary palettes. So, simply click it and then press delete. All right, let's redo it with a big palette. Let's make it more big. How? Okay. On the upper right side of my screen, I have here icon for zoom in. Right? So let's discuss again. Okay, let's make it move. Right. So we have here the start palette. And then next to that, we drag a move steering block. Okay. So let's discuss the configuration. The first icon bar refers to the mode of operation. So on our end, we pick on for seconds. All right. And then the second icon bar refers to the direction of the motor. As I mentioned, the direction of the motor is connected to the third icon, which is the motor power. Positive motor power is directed to move forward. And when we change it to negative 50, it will automatically change direction. To simplify, positive figure is for moving forward and negative figure is for moving backwards. Right? There you go. So let's change it to forward again. And then the port icon is for us to configure the mode of operation. So going back to the first icon, we pick on for seconds. And how many seconds would be the movement of my robot? 2. Right? And then check for brake. So it will automatically stop on the given on the given number. Right? There you go. And then let's go back to the BRT simulation application. We need to connect our robot first. How? We need to go there to the hardware page. Okay, so I think for you to see the created code and the simulation app, we need to control our windows. So let's pick the windows for the simulation app and the programming environment. So this is the created code, okay, for the 2 minutes movement, the 2 second movements rather. And then we connect our robot via hardware page via Bluetooth. Okay, there you go. And then at this moment, we'll go to the simulation environment wherein we will test the created code. So what we need to do is to go to the toolbar again and press play. And then right after that, we need to press the play palette also on the programming environment. Right, there you go. And automatically, the robot will move according to the created code. Right? And then, as you can see, okay, let me show you closer my robot that is on the game mat. Okay, let's view the camera mode for you to see the complete angle. Right, there you go. So as you can see, I have here a basic robot. A basic robot that comes with the motor. Okay. Now, there are also ways on how we can add attachment with our robot. Right, Sir Mark, is there any questions?
Yes, so thank you, Ma'am Annalyn. So I'd like to also share the comments from our participants. Of course, not all of them are able to follow because of some hardware issues. Their laptops are not in accordance to the requirement, the specific or basic requirement of the application. So I think,
Mhm.
of course, our teachers are as much as possible they want to follow. So we have this team replay later on, and if you have any suggestions, what they can do if the requirement is not appropriate or not applicable for that specific application or that particular application. So what they can do, ma'am?
All right. So, as you can see from the presentation, using this virtual application, we are using three environments. So, meron
Yes.
tayong simulation environment, which is the Virtual Robotics Toolkit. And we are also using the EB3 Lab environment, wherein we will use that software for programming. And we also have the learning resources environment. So technically, teachers, gagana lang po talaga si application base doon sa requirement device. Kasi po medyo mabigat po yung mga embedded software and application in order for us to beautifully simulate the given task. So hindi po siya gagana sa mobile phones, hindi rin po siya gagana sa tablet.
Yes. All right. So I think teachers will are very resourceful and will find ways on how they can really follow up or follow the robotics. Of course, this simulation is very essential, very helpful
Mm-hmm.
for us to really understand how this robotics will work. How it, even though we don't have the physical robot. So
Mm-hmm.
as promised, Miss Annalyn by Miss Mylene, we have our guest, special guest, our very own learners who are winners of our first Philippine Virtual Robotics Challenge. So, with that, let me call in our winners from DepEd Manila. Our third place, Sire Benedict V. Garcia from Aurora A. Quezon Elementary School. Our second place, Aliana Denise Beato from Abeca Academy. And our first place, Owen Justin C. Gocheco from Quezon City Christian Academy. So I think they are going to share their experience, a short demo on how they were able to, of course, to succeed and how they're able to use the robotics or the robots.
Hi kids!
Hi, Sir Benedict. How are you?
For our viewers information po, pinaalam po namin yung ating mga bata to do the demonstration. And thank you so much kids for attending this webinar. Are you ready?
Yes.
All right, take it away.
Hi, and good morning. We are the top 3 winners of the first Virtual Robotics Challenge. My name is Sire Benedict V. Garcia, and I'm 12 years old, from Aurora A. Quezon Elementary School. WRO 2020 is all about Climate Squad. You will act as the Climate Squad that will develop the robots that will allow us to adapt and help us overcome the increasingly frequent climatic hazard.
Great.
On,
Go ahead, Sire.
on my screen is the default working space of the Virtual Robotics Toolkit. On its upper corner is the simulation space for VR, while on its lower corner is the working space for EV3 where we do programming. This is the game mat we use for Elementary 2020 Challenge. These are the code that we will use in order for us to do the complete execution of the task made by Owen Gocheco.
Hello, I am Owen Gocheco, 11 years old from Quezon City Christian Academy and a member of iCreate Manila since 2018. I've been joining different robotics competitions like Philippine Robotics Olympiad, First Lego League Philippines, and World Robot Olympiad Thailand last 2018. I am going to show you my program for my WRO virtual challenge going to the blue, red, and home.
Wow. Awesome.
So right now the robot is approaching the first task. It moved the tree without touching any black lines. Now the robot is going to the second task. It collected the blue water tank and now will be placed on its designated position. Third, the robot will now get the medical kit and will be placed on its designated area. Now it is approaching to its designated place. Lastly, the robot will now return to the home, which is the finish area. This is my virtual output I used for the first Philippine Virtual Robotics Challenge.
Hi, my name is Eliana Beato. I'm 12 years old and I'm studying in a Becca Academy. It was 11 months ago when I started with I Create Cafe. It was a fun experience and I have learned a lot from the actual manipulation and coding of my EVG. Until the lockdown, I thought I will no longer be able to practice my robotic skills. Then, I Create Cafe invited me to continue practicing using Virtual Robotics Toolkit. At first, it was semi-hard because of the changes from the actual robot to the virtual one, and given that I was a beginner on this program. But eventually, with the help of my coaches, I was able to enjoy the experience with continued practice. It is now easier to build the robot, and programming feels the same thing from the actual one. Thank you for the virtual version of robotics. We are still able to pursue and continue learning and joining robotics competition like the first Philippine Virtual Robotics Challenge.
Wow, amazing. So, congratulations, kids. The three of you. We're very happy to know that as early as your age, you have that passion for robotics, you have that critical thinking, you did problem solving skills, and you have this, although it's not yet deep, but we'll go down the road there, and we're very excited for your future. So I believe, and we can say that all your parents are very proud of you. Talagang they're very supportive, and we can see that your future, the brighter future ahead of you. So Aliana, any message since you're the girl, only girl on the top three? I believe you can also share something for our young girls out there, your learners out there who would like to have passion also, or any advice for them?
Just continue with your passion, and for sure, there's supporters out there for you.
Yeah, so continue that passion. So how about you, Owen? Our first placer. Any advice for kids out there? How they can start? Oh, I think Owen is shy. So, Owen? So I believe this similarly. Owen would like to share his passion by, of course, learning by doing, right, Owen? And how about you, Sire? Any advice or any tips?
Trust yourself for whatever you do. Continue your passions.
Yeah. So wow, what a very passionate kid. So may I call in Miss Annalyn? Any thoughts about these kids and any experience since you're there watching how they perform in the first ever Olympic Philippine Virtual Robotics Challenge.
All right. So we're very grateful that we have this type of kids in I Create Cafe Manila. They're really into the program. So for the whole quarantine time, we are seeing each other and practicing for. We joined this kid with the first virtual robotics competition here in the Philippines. Um, Thank you so much for the continuous support in I Create Cafe Manila. Thank you so much as well for joining this webinar for you to share your experience in insight with virtual robotics toolkit. So you can now enjoy your your lunch. All right. Thank you so much for joining us today.
kids. So congratulations. So as per Brian, Mr. Brian, great job. Continue that great job. Oh, hi Brian. Yeah. Any message to our kids and Filipino young learners?
I think it's amazing to see what they are capable of doing, and we're just looking at the robot running around on the field. It looks so easy and simple, but the amount of hours and time spent there figuring out how this is done is absolutely amazing. I think so. Congratulations! I think you did a fantastic job. You make it look easy, and it is hard fun and a challenge, and requires a lot of practice. So we're very well done.
Yes, congratulations, kids.
Actually, Sir Mark and Sir Brian, for your information, most of our kids are really Lego enthusiasts. So almost every weekends they are in the center doing their Lego activities. And then when we experience the COVID-19 pandemic, they keep on pushing us, teacher, how we can continue despite of
Wow.
this situation. Luckily, we have this virtual robotics application in partnership with BRT Group. So the learning and fun continues with the kids here in the Philippines. So for all the teachers out there who is watching, please continue studying the virtual robotics application. This might be the beginning of your robotics journey using Lego Mindstorms EV3 education set.
All right. So thank you, Miss Annalyn. Thank you, Brian. We're not done yet. So congratulations, kids. And I hope you continue your passion and love what you're doing. All right. Take care.
Thank you.
Thank you. All right. So Teacher Annalyn, you may now continue the simulation and how we can really our educators much appreciate it and how they're going to apply it in their online or respective class. Thank you.
All right. All right. Thank you. All right. So while I'm setting up again my BRT software, for all the educators who are watching right now, um, after this webinar training, I'm going to share a tutorial video on how you're gonna use the BRT software together with EB3 software for your reference. All right. So going back to the discussion, at this moment we are trying to execute the respective tasks. So from my screen, as you can see, we have on the top, we have here the simulation environment, wherein we have the game mat and the virtual robot. And then on the lower part of my screen, I have here the EB3 programming software, wherein we did our coding. Please take note on this sample demonstration. We will make our robot move forward for 2 seconds. So let's try to read the palette again for review. So I drag here a move steering that consists of two motors. So from here, okay, we need to configure. So first icon bar is we have here the mode of operation. So there are different options that we can pick. On our end, we pick on 4 seconds. And then the second icon bar refers to the direction of the motor that is connected to the icon bar for motor. Again, positive figures is for moving forward, and negative figures is for making the robot move backwards. All right? Let me show you again. So as you can see from my screen, okay, it's changed the direction. But on the given task, we wish the robot to move forward for 2 seconds. So let's make it 50 again. 50 is the standard motor that we usually use for the motor power. But it always depend on the given activity, right? And then how many seconds? Let's make it run for 2 seconds and then break. Right after we accomplish the certain code, okay, what we need to do is go to the hardware page area, okay, this side, wherein we will connect our robot to the EB3 digital robot. Okay, in a piece-to-piece activity, we connect our robot via Bluetooth. So we have here the red icon, an indication that the robot is already connected with the device. Okay, there you go. So let's now try and run our robot. So we need to go back again to the toolbar, and the third icon is to reposition the robot. All right. And then what we need to do is press the second icon bar, which is the play button for the simulation environment. And then go back again to the EB3 lab environment to run our created code. And automatically, our robot will move according to the given task. Okay, let's say that we wish to add more movements to our robot. What we need to do is simply add blocks. So let's say that we want the robot to move forward for 2 seconds. Okay, and we want the robot to move backward. Okay, what we need to do is to add additional blocks. So let's drag again move steering block and configure. Mode of operation, on for seconds. And then motor direction, let's make it -50, so it will move backward. And then how many seconds? Let's move it for 2 seconds. And break. So it will stop according to the given figure. Then test it again. So we need to go back to the EB3 simulation environment. Again, this is how you're gonna reposition the robot. Press the third icon, and then press again the second icon bar for play, and play also the created code. So it will now execute move forward for 2 seconds and move backward for 2 seconds as well. All right? There you go. So that's how we do coding. It's very simple. Now, let's explore the different functions of a toolbar. As you can see, we only have here the basic design of robot. Now, let's try to explore the port icon bar from the toolbar. This icon bar is for us to manage the attachment of the software. All right. So as you can see from my screen, I have here the available attachment that we can add up with our robot. We have here the lifter, the gyro sensor, the ultrasonic sensor, the color sensor, and then a touch sensor. All right. So from the basic robot, what we wish to add is the complete electronic components, okay? So first is, let's add the lifter. So click it, then simply click add, and automatically it will be added to our robot. And then when you are good already with the positions of the lifter, simply press OK. All right, let's see the view mode. So as you can see from the basic robot, we already got there the lifter for our robot. Okay, now, so what would be the functions of this robot? As I mentioned a while ago, we use this for the extra movement of the motor, okay, or extra movements of the robot, because we usually we usually use the large motor for the basic movement. Now let's try to program the lifter. So on our end, okay, let's drag a medium motor and then configure mode of operation. Let's pick on for rotation. And then we have here the second icon bar is for the motor power. And then the third icon bar is the option of how many rotation that we wish to execute for the medium motor. Let's say that we only pick 0.3. All right. So let's go back again to the simulation application. So on the lower part, we already added the medium motor. Right? So what we need to do is control our robot via toolbar. So we need to reposition again the robot. So we need to press the third icon. Right? And automatically, it will go back to its original position. And then right afterwards, we need to click the play icon bar. And then right afterwards, play again the created code. So this is the thing. The robot will move forward for 2 seconds and move backward for 2 seconds. Wait. Let's have the lifter first. As you can see, there are errors, but errors is part of the learning process. So let's try to configure what's wrong with the created code. So let's reposition again our robot. And let's see, oh, wait. We don't have here the attachment. So let's go back to the attachment icon bar, lifter in front, add, and okay. Now, before we run our robot teacher in EB3 lab environment picture, we can actually test a certain palette. Let's try first our medium motor if this code is already working with the lifter. So just simply highlight, connect to the hardware page. Sorry. Okay, so there is something wrong on our code. So let's change. Highlight and run. One more. All right, so it's working perfectly. There you go. So as you can see, the program for the medium motor is for making the lifter up. Okay. Then we can also add up another medium motor for the execution of the lifter going down. So as you can see, the coding is very easy, but the logics enter here. And every movement is equivalent to each action block. Right? So for making the lifter up, we use here a positive figure. And for making the lifter go down, we use the negative figure. Okay, let's try to run first. All right, there you go. So let's reposition and run again. So before I run this, let's read the palette. Our robot will move forward for 2 seconds. And then right after 2 seconds, the robot will move backward for 2 seconds. And then the robot will make the lifter goes up. All right, up and down. So let's press play from the simulation environment and play as well to the EB3 environment. Forward, backward, and lifter, up and down. All right, there you go. So that would be the functions of the lifter. But technically, on the given output, what you need to do is to get the cuboid. All right. So we need to have a measurement in order for us to get it accordingly, right? But let's go back first to the attachments. So we can add lifter to the robot. We can also add sensors. So let's add ultrasonic sensor. All right, there you go. Click and add. Okay. Now, so what would be the functions of this ultrasonic sensor? From my actual demonstration a while ago, as you can see, we use this ultrasonic sensor for measuring distance. Now, for this kind of given activity, using an ultrasonic sensor will be a great help for us to make the code more easier. All right. Okay, let me show you first the actual challenge. So let's go back to the virtual simulation application. Right? Now let me show you the, okay, let's reposition a robot again for you to see the actual challenge. The good thing about with this virtual simulation application, as you can see, there are embedded activity from the task, like what we are using in the sandbox area. Now, for your homework activity, okay, let me show you the lesson plan. What you need to do is go to the home page, go to sandbox EB3 topic, and click read more. All right. So for this activity, okay, in getting started with EB3, our overview here is the purpose of this project is to learn how to use the simulator controls. So what would be the objective? Learn the stop simulator icon bar, practice driving the robot, open and close the EB3 brick, add and remove attachment. So look at this hint for you to control the robot. Start and stop the simulator with the play WASD function on your keyboard, right? To drive the robot with the on-screen control, please see the key and control the camera with the on-screen mouse control, right? So this one would be the getting started activity. What we need to do is simply open the EB3 virtual brick by clicking on the view menu that we're done with that already and selecting EB3 and press the middle button to turn it on. And loading programs we'll discuss in another project. And then we're done with the select buttons and we have here EB3 sample code that you can use for your references. Now, going back to the simulation application, Let me show you on how you gonna do the sandbox challenge. Ha? Ano? Ano? All right. So let's go back to the simulation application. Okay, just for a moment, it's loading. So that would be the objectives of that sandbox challenge. Okay. The objective is for us to understand on how we will navigate the application itself. Okay. Let's reopen the software. Okay, let's go back to the toolbar and move to the sandbox challenge. All right. Okay. All right. So as you can see from the game mat, we have here area which is color red, color blue, okay, color green, and color black. And there are different elements, okay? So for our given task, for the concept of movement, okay, what we need to do is simply place all the blocks to those designated area, right? So sample movements. Okay, let's try to create a code. So technically teachers from the robot original position, okay, what we need to do first is to create movements going near to the elements. Okay, so that's for making the robot move forward. So reading on the thing, there are three different objects that we need to get. All right. So first is let's have first the first element on the middle. Right. So we need to practice measurement here. All right. So let's try to create the first code and let's make the robot move forward. And our target is to get that element in the middle. Right. Let's try and test. Right, as you can see, 3 seconds is not enough, so we need to add some more. Let's make it 4. There you go. So it's closer already to the robot. What we need to do is automatically turn. Right, so let's configure. And let's make our robot turn a little. So let's pick on for rotation. 1.3 will do. A little tight turn will do in order for us to get that element. So let's go back, reposition the robot and try. So on the given palette, we're making our robot move forward for 4 seconds and then turn. There you go. We got it. And then right afterwards, we need to place it on the blue area. So what we need to do is add again another move steering block for forward. Right? Let's pick on per seconds and let's make it move for 2 seconds. Okay, run it. Reposition again. Run to the simulation environment and run it to the created code. All right, there you go. So that's the thing that we will be doing. So for your given homework, please continue the EB3 sandbox activity. So for this certain activity, you'll be using a lot for action blocks. So we'll be using only the green sets of palettes for movement. And what you need to do is simply deliver all the three elements in the side. All right, there you go. All right, let's go back to the home page. All right, teachers. So as you can see, we have here a different activity that we can explore. But for your homework, I want you to continue the Sandbox EV3 challenge. Wherein our objectives for this activity is to learn the basic of the simulator by driving a robot in an empty room. All right, Sir Mark, I think that's all that we can share for a virtual robotics toolkit simulation application.
All right. So again, a
Yay!
virtual applause to teacher Annalyn, to Miss Annalyn Aban from Felta Trainer. So, Ma'am Joy?
Yes, so we will have questions. We'll answer some questions
All right.
of our participants. Let's see. Ayan. So, do they have any questions?
All right. So,
So Ma'am Mylene is back also.
Yes,
Hello,
I'm back.
ma'am.
And then we're waiting for Priyanka, and I don't know if Tim is still awake.
yes, Miss Joy,
Hold on.
loud and clear.
And Brian is
So,
I know
yeah,
he's
common.
all right. Here's Brian.
All right. So Sir
We
Brian's
have
still
Priyanka
there.
and we have Tim is there. All
Hi.
right. So questions on the
I'm still
floor.
here. Absolutely.
All right. I just want to make an announcement so that we are clear that the extended virtual robotics toolkit licenses will only be given to the DepEd educators or parents who have participated in this webinar. It's not fair to give it to those, iba, nag-effort sila eh. So they have really participated, and we coordinate with the Department of Education, Educational Technology Unit, and FELTA will be the one to coordinate with them for the deployment of the license scheme. And we'd also like to announce that the license key cannot be shared. Isn't it right, Priyanka and Tim? It's IP sensitive.
Yeah.
Is
Yeah,
it?
it is.
Yes.
Yeah.
All right. So if once you have it, please take care of it, and because that will be downloaded in your own device. So only one per person, and only for the Philippine Robotics Academy schools will be offered the extended. These are for the private schools. I mean, because for the DepEd, of course, we have the arrangement for coordination with the ETU, And for the private schools, it will be offered for the Philippine Robotics Academy schools. So these are the schools who have integrated the robotics technology program in their curriculum virtually. Yes, so I hope that I am clear. All right. And do we have questions on the floor? I think Brian has an announcement as well.
Yes, Miss Mylene. So most of the questions, I think it's more on the hardware issues that they cannot download it or it's not compatible in their device. So again, as mentioned earlier, our teachers are very resourceful, and they will really find ways to really use this robotics, especially this virtual robotics toolkit, which is I'm really amazed. It's a very powerful tool to really enjoy and to really test your robot.
I think Tim and Priyanka can also share before we go to Brian's announcement. They can share about the efforts that we understand that i3 or i5, i7 laptops may not be available for the teachers or the educators. Priyanka and Tim, can you share with us the efforts of having a lower system requirement for the virtual robotics toolkit?
Yeah, so right now, as VRT stands, you will be able to download it on i3 or i5 processor, and you'll be able to open the basic challenge maths and work with them. Heavy maths like WRO and FLL might not open on a very basic machine like, let's say, i3. But if you have i5, i7, you should be able to open heavier maths as well. What we are doing is we are working on a simpler version of VRT that doesn't require as much horsepower as the one that you are using right now does. And we'll definitely keep you posted for once that is available. So either a web, actually it will be a
Great.
web-based version of VRT that'll be available in the future. So you'll be able to load it on cheaper machines like Chromebook and stuff. We are definitely working on that so everyone can use VRT.
Yes. So
Yeah.
yeah, in fact we sent a sample of the laptop that Felta produces with in cooperation with Intel Education to Canada so that they can test it. So yeah. So
Yeah, we are
for
waiting for that.
yes. Okay. So Tim, do you have anything or do we have other questions? Any other than the hardware requirements?
Well, I just like to say how well
Tim.
I was just going to say how impressive this entire enterprise has been. I'm very impressed with the caliber of the people and the kids that you had on here that had done all that work, and your instructors. This was just a great show. Thank you very much for letting us be part of it.
Thank
Yes,
you.
aren't they amazing? Yeah, they're really amazing.
Yeah, it's
Yes.
really
And just for
amazing.
the yes, and please note, I'd like to emphasize that Sire Garcia is from DepEd Manila, so he is studying at Aurora Elementary School. So it doesn't mean that if your virtual robotics is only for private schools. No, we are offering for all schools. As I mentioned yesterday, we are really very passionate about robotics for all. Right? So
Mhm.
everybody should be able to learn robotics. Okay, so maybe we
Yep.
can ask Brian. I can see the daylight already at the back of his curtain. So
Yes.
it's already it's already daylight from night to day. Okay, Brian. So you can have your coffee, your morning coffee.
Yeah, exactly. The sun is rising. It's a beautiful morning in Denmark, so that's great.
Yes, okay. So Brian Dam would like to make an announcement. Well, this will be a special robot that was just recently launched a few months ago. And Lego Education is very thrilled to offer this specifically for the elementary school. So, Brian, take it away.
Yes, thank you very much.
Yes,
So, as as
share it in
Mylene as Mylene
webinar.
shared, we have now in Lego Education a new product arriving here in 2020, and that is called Spike Prime, and we are of course super excited and proud about it. It has been mentioned several times over the last 2 days now that robotics, that is for everybody. And that has been the exact purpose when we have been developing the product. The core product has been exactly that, to design a very intuitive product, both when we are talking about the whole building experience, but also when it comes to coding. So this product comes with a promise of a low floor and high ceiling, meaning um, that it is very easy for teachers, for both the teachers, but also, of course, the students, um, to get started with, while at the same time having the strength and the bandwidth to still carry out very challenging and demanding tasks. So that is exactly what is needed at the moment to also build upon the confidence of both the children and, of course, the students. The curriculum and content that has so far been developed around Spike Prime is based on business or learning units. So we have 4 learning units in the set now: Life Hacks, Kickstarter Business, Inventor Squad, and Competition Ready. And all of these are, of course, built with the focus on the future required skills, so the top the 21st century skills. They are also based on the NGSS standards. And that is again, has been mentioned before, that is to make the robotics as an integrated part of the curriculum. So we are hitting and ensuring that we are at the same time introducing a new way of teaching, but at the same time doing this with a core aim of developing also the core curriculum skills. So we are, of course, super happy and proud about this, and I very much hope that you will be willing to try, test it out, and see what it is capable of doing. So thank you very much for allowing me to make this very, at least from our end, proud announcement.
Thank you so much, Brian. And for the information of our viewers and specifically our educators from the Department of Education, we, Felta Multimedia, have already conducted a Spike Prime training on robotics readiness at the Ateneo de Manila University and at Miriam College Innovation Center a few months ago, also sometime last year. So we're ready, and we are going to be coordinating with the Department of Education Educational Technical Unit to build a Spike Prime community. So this will be an initiative, hindi pa alam ng DepEd, hindi pa alam ni Sir Mark Siang, but I have already gave him a filler that the ETU will spearhead the Spike Prime community, where we will build lesson plans and other activities free for teachers to use. So that will be coming up soon. So now let's announce some of our winners. Yes, yesterday you were able to make a duck, isn't it? And we saw your wonderful ducks at the DepEd ETU Facebook page. And we are now going to give prizes to 3 lucky, I would say not lucky, but deserving winners of the duck. Once we announce your name, may we ask also the DepEd ETU to help us trace them, because we only have their names. We don't have their mobile numbers or their school names. So the first winner, can we show our first winner, Miss Chair David? So if you see yourself here, or if you have a friend, yeah, congratulations. May dapat may S. Kulang.
Wow. Congratulations.
Can we make it bigger? So, yeah, so we have Chair David, and we have, can we have Jacqueline Coro, and we have Christina Bohol Kainya. Congratulations.
Okay,
We have the 3 winners of the Lego Education Digital Designer Duck yesterday. Yay! Congratulations.
Congratulations.
Yes. Yay! The duck will come from Lego Education Denmark pa. No,
Wow.
so that's the Lego Education Duck. We will give you your prize. Okay, well, we may we turn over now, Sir Mark and Miss Joy, if we can ask our special guests so that Tim and Priyanka can sleep and now Brian can take his coffee. Kawawa naman sila. Their final words or any messages for us, Sir Mark, uh, Sir Mark, or Sir Tim, or you have any messages for us before we announce the raffle winners?
You're muted.
You're on mute. Yes.
We cannot hear you.
Tim?
Okay. Yes. Okay. Tim, you're on mute. All right.
Maybe we can hear it from Priyanka.
Yeah.
Okay,
Yeah,
Priyanka.
yeah, yeah.
I
You're
would like
on.
to thank.
Tim left.
Yeah, I will talk.
Very
I will
ready.
talk. Well, I would really like to thank you all for having us here today. It has been a pleasure to, watch the Virtual Robotics Toolkit journey, how it started with, just the Felta team knowing about it. And now the kids are trained in it and they are doing demos with it and showing their programs. It was really inspiring. And just seeing the confidence and that the kids got by practicing using Virtual Robotics Toolkit just made me really happy. So I just would like to thank you all.
Great. Our Tim is back. Tim, please
Yeah.
unmute.
Hello, Sir
Still
Tim.
muted. Still
Tim,
muted though.
I know.
there you go.
You're
There.
There.
Yay.
Hey,
Okay, so you can sleep.
See,
Okay,
and
Tim,
I
your
didn't do
final
anything,
word.
so it wasn't my fault. Okay, yeah, again, this was an amazing evening, and I'm so proud of being able to see all these kids, and we really look forward to working with your group and hopefully Lego as well, and moving this forward and getting more and more kids involved all around the world. So again, thank you very much for all this work. It's very much appreciated, and we're very excited.
Thank you, Tim.
hey, thank you, Tim.
Thank you.
Thank you.
Okay,
Yes,
Sir
take care
Brian.
always. Stay healthy.
Yes, I'm more or less gonna echo Priyanka and Tim. I think it has been two fantastic days. It's amazing to see the progression that has been taking in the Philippines and all the initiatives that are being carried out, and of course followed up by an outstanding performance of our students coming in and showcasing everybody that. With confidence and with effort, everything is possible, and I think that's super inspiring to see. So thank you very much for allowing us the opportunity for being here and putting on such a nice show. Thank you.
Thank you.
Thank you, Sir Brian.
Thank you,
Thank you so
Brian.
much.
You can take your coffee.
Thank you, Brian.
Your coffee.
Thank you.
All right.
Thank you.
And then Priyanka and Tim can now go to sleep. Thank you. Oh, Sir Mark!
Sir
Yay!
Marcy.
He was able to catch up. Sir Mark, can you give us your? I'm sure
Thanks
you're
so much.
monitoring.
Bye-bye.
May I
Okay,
introduce
bye-bye.
Sir Mark Anthony C. Tim, please don't leave yet. He's
Okay.
the head of the Educational Technology Unit. He's the brains behind all these webinars that the Department of
Oh.
Education has been going to bridge the technology gap from the teachers and to reach out to as many educators in the country. So may I introduce Tim Shea and Ms. Priyanka Petuha from Cognition Robotics, and you have met Brian Dam from Lego Education, so he's back. So Sir Mark, can we hear from you?
To our partners, Ms. Mylene, Sir Brian, to Sir Tim and Ms. Priyanka, thank you so much for allowing us to be part of this important activity. I always dream about this, to have the robotics program for the public school system, not just only for a few. And when I was given an opportunity to talk with Ms. Mylene, uh, I just felt that it's really now high time for us to move forward and not just simply telling what other schools can do. That ed can do it. It's just a matter of pushing our teachers, looking for the perfect people, looking for a perfect partner to conduct this and also to augment that one, because at the end of the day, it's for the benefit of our learners. So please uh, do not hesitate to contact us from time to time and be patient if ever we contact you. And then let's continue our collaboration. And I hope that with whatever we have in this robotics field, it also be inclusive for our learners, because I'm very passionate now in extending our program to our learners who are deaf, also with the blind. And I'm very happy that I slowly acquired those skills right now. So I will do my best to augment it and bridge our learners also to learn robotics even if they are blind or even if they are deaf. So we will work on it, Miss Mylene. So thank you so
Yes.
much, and
Thank you, Sir
God bless
Mark.
us all.
Sir Mark. And if I may add to Sir Mark's comment about inclusive education in robotics, I'd like to inform you that even for the past 5 years ago, we have already been teaching robotics for the hearing impaired in the Southeast Asian Institute for the Deaf. And also for in I Create Cafe in Manila, we've been teaching autistic children. So I think we're aligned with your goals, Sir Mark, to make it inclusive, not just for the regular or the normal children, but to make it for all children, regardless if they are special or they're regular or normal children. So yes, thank you so much for bringing that up. Okay, now we will announce the raffle winners before we end the show. Do we have the raffle winners? May I do a shout out? We have the robotics team from Bohol, DepEd Bohol. They've been watching since yesterday. May I just do a shout out? Kundi aawayin ako nitong nila. We have Brian Asilo, Engineer Rons, Engineer Misael, Engineer Jewel, Ian, Odessa, Joy, Henry, Jaime, Nisham, Jimmy Ochona, Flor Lopena, Flor Saging, Erickson, Gina Odal, Ariel, and the EPS Dr. Gracio, and the head coach Tata Celeres of the DepEd Bohol. Ayan, buhay na ako kasi I have to do a shout out to them, and also our friends from Project 6, DepEd Quezon City, Project 6 Elementary School. They've been following, and also our friends from Lapu-Lapu, Ibo Elementary School, our scholars for the 9th Philippine Robotics Olympiad. They received a Disney grant to come to the Philippines for the 9th for the first Lego League. So they're Disney grantees. So yun po, mga shout out. And our winners for the raffle, may we show
Ah,
our winners for the raffle. So again, ang ating mga raffle items, nila, parang online shopping, you know? You have to give me refill. Online shopping. So this is the keychain that you will win, and then this is the ID card holder. These are all, and then you have the robot keychain. Asan? Tumatalikod. Ayan. So robot keychain. Ayan. Parang online shopping ang dating. Ayan. Ito po ang mapapanalo nyo. And we have the Lego Education Notebook. All right. So can you
Wow.
flash
yay.
pictures? So all this will be sent to you by courier. What we need for you to do is give us your name, school name, and your address. Please send it to our friends from the Department of ETU, Educational Technology Unit. And Sir Mark and Sir Joy and Sir, to dalawang Mark, please also announce about the output. I think before we announce before ma-excite lahat, where they will submit the output, because we've been having a lot of inquiries where they will submit the output. Diba? Si Annalyn
Yes,
po
Miss
hindi na
Mylene.
natulog.
Yes, Miss Mylene. So, in addition, Miss Mylene, so para hindi lang masyadong, I know marami excited tayong mga webinar participants, but we will also like to give way sa ating mga team replay. So, Miss Mylene, we will post the winners of our raffle, and they will see that in our edtech page, so that we can also accommodate also those teachers who are in the school doing enrollment, but they will catch up in the afternoon. So we will have our raffle in the afternoon. We will post that in our edtech page.
Page.
Okay, so bili pa lang.
Yay.
So suspense muna.
Suspense muna.
Yes,
Suspense muna.
pa-excite lang.
Ma-excite. Pinapa-excite lang natin. So ito yung mga mapapanalo nyo. So pumunta kayo sa, ano sir, what do you call it? Replay team? Anong tawag?
Yeah.
We are the team
Replay.
Team replay. Ayan. So mapapanalo nyo. Alright. Okay. So any other announcements? Yes. Team replay for this. I think for us then we can show our video. We'd like to announce the please download. The last part of the video is the screen of the links that you can download the Lego Educational Digital Designer and the Virtual Robotics Toolkit license.
Yes.
Again, Sir Mark, we will only give the, because you were a bit late when you entered the Zoom the StreamYard. We will only give the free extended license to those deaf ed educators who are in the webinar, to who attended, sir. Kasi para fair naman po, di ba, sa lahat. So only those who have attended and who will also receive their certificate. Yes. And then for the private schools, only schools who are in the Philippine Robotics Academy schools. Yun lang po ang bibigyan ng free extended licenses. All right. So,
Yes.
yay!
Hey, so again, thank you,
so much.
Brian. Thank you, Priyanka. Thank you, Tim. Thank you, Miss Mylene, Miss Annalyn,
Thank you.
for your generosity, your time, and effort, your love for the Filipino learners, for our Department of Education. Maraming salamat po at mahal na mahal namin kayo. Joy, any message before we leave?
All right, so thank you so much, especially to Sir Brian, Sir Team, and actually, may question dito, what is the complete name of Priyanka? Anyway,
Just Priyanka.
just Priyanka. Yeah. So, thank you especially to Ma'am Annalyn for your patience in answering the queries of our participants. Thank you, Ma'am Annalyn. Thank you so much. Okay? So,
Yes.
Let's
So
show the
again,
video. Bye.
to our educators, raise confidence of our learners, ignite their passion, inspire, and develop the builders of tomorrow. Happy weekend! Happy Friday! Have fun!
Happy
Happy
Friday.
lunch!
Di mo naman sinasabi,